Hello, hello. Today we're going to talk about the big three. So this should be a pretty quick one. Just want to give you a quick review. Average velocity is given by the change in displacement over the change in time. But there's a caveat with this. We can only use this equation if there's no acceleration. You need to use three formula when acceleration is involved. So these are the big three, or the big three equations. So you're going to get pretty familiar with these. AP has their own style of the big three. That would be using just slightly different nomenclature. So instead of using D for displacement, they're using X for displacement if you're moving horizontally. For moving vertically, we'd be using Y for displacement. And instead of really outright saying D or displacement, they're kind of separating this into position. So we have an initial position here and a final position here. So they've really separated those out for us. So you'll notice that in the differences between these two equations. The simplified ones are the ones that you'll probably see me write down more because that's what I've grown to use, and it's fewer variables, and so sometimes it's easier for people to remember that if you can remember that D is displacement, and so it's the difference between your initial position and your final position. Okay, so we've got V equals V naught plus AT. A is acceleration, T is time, V is your velocity. Sometimes you'll see it written as V sub F for final. Sometimes you'll just see it written as V. And then we have V sub naught for initial. Sometimes you'll see it written as V sub I, depending on what source you're looking at. And occasionally you'll see this as V sub 2 for final and V sub 1 for your initial. All right. So that covers our big three. I'm going to do a quick example problem, and then we'll move on to free fall. So we have this quick example. A clown car traveling at 7 meters per second east speeds up to 22 meters per second east in 1.7 seconds. What is its acceleration? So we have a lot of values here, a lot of numbers, and it's helpful to, number one, draw a picture. And then number two, write down what you have, your knowns, your givens, and then write down what you are looking for or what you don't have, your unknown. So I'm going to go ahead and we'll draw this out here on the side. So for number one, what we know is that this car is traveling east, so to the right, at some velocity. Okay, so we have an initial velocity. V naught is 7 meters per second. And then it says it speeds up to 22 meters per second. So that would be its final velocity. We'll write VF. Its final velocity is 22 meters per second. And this is happening in some time. It's happening in 1.7 seconds. So we are given the time as well, 1.7 seconds. All right. Make that a little more clear. There we go. So 1.7 seconds is our time. What we're looking for is the acceleration. So we'll put A equals question mark. And again, this looks tedious, but this really helps you set up your problem. It helps you figure out what you have and what you don't have. And that can help you figure out what tools you need to solve the problem. Other benefit to this is that on your homework, I'm requiring you to write down stuff like this. This is part of showing your work. And on the AP exam, it's not just for me to kind of gotcha. It's number one, because I've given you the answers on your homeworks. And so what I'm looking for is your problem solving process, not did you get the right answer? It's how did you approach the problem? And number two, on the AP exam, they're also looking for that. So there might be times where you're going to be asked for your knowns and unknowns and for what equation you're going to use on the AP exam. And they might not be looking at all for an answer. They might just be looking for what tools did you use? So it's really important for you to do that. So if we go ahead and we look at the big three, we've got V naught, VF, T, and A. So we need to find an equation that incorporates all of those. It doesn't have anything extra. So if we go back, let me change my pointer here. So if we go back to the big three, we've got this equation up here, the first one, V equals V naught plus AT. So we'll come back here. And what I want you to do when we're solving these problems is I want you to write out that equation without any values. So VF equals V naught plus AT. Okay. And then the next thing I want you to do, the next thing that you must do, is rearrange this equation for your unknown, which is A. So we're going to do A equals, we've got VF minus V naught divided by T. And if you're not sure how I rearranged that, again, you need to do some algebra review, maybe check out Khan Academy, or look at one of my math review videos. Okay, so now we have this equation solved for A. And again, this is essential for AP test stuff and just for being good at problem solving. It helps eliminate mistakes if you can solve for the unknown before you plug in your values. So now I have this equation. I know my final velocity, it's 22 meters per second. I know my initial velocity, it's 7 meters per second. And I know my time, it's 1.7 seconds. So again, be careful following order of operations when you're doing this. You do 22 minus 7, and then divide that by 1.7. So that gives me an acceleration of 8.8 meters per second squared. Remember, accelerations are squared, meters per second squared, because they're meters per second per second. So that's our answer. And again, when you're doing a homework problem for me, please put a box around your answer so that it's easier for me to see it. Okay, so the rest of these examples use one of each of the other big three, and I urge you to practice them just to give them a try. And again, what you're looking for is what you know, what you don't know, rearranging your equation for what you don't know, and then you can plug in your numbers and calculate it, watch your order of operations, and make sure you have the correct units. Other thing to note, when you're doing practice problems with these things, sometimes you'll be given values that are in kilometers per hour or some unit other than meters per second. So remember our special number, that 3.6 number that we can use to either divide or multiply something by to go from kilometers per hour to meters per second. So make sure when you start a problem that you're looking at these units and that you convert your units first, okay? Because we should always be working in meters per second unless the question explicitly asks for an answer in hours or kilometers or something of that nature. Okay, so we're going to move on to free fall briefly. So we have this thing called acceleration due to gravity. Okay, we got my little Wile E. Coyote here, and we'll do some Roadrunner physics later on, so you'll understand later why I have Wile E. Coyote there. So neglecting air resistance. That means if we forget about the push and pull of the air around a moving object, we're going to say that all objects fall at the same rate. And we'll discuss why when we get into dynamics and forces. We'll talk more about why this is the case. So acceleration due to gravity near the Earth's surface is always going to be negative 9.8 meters per second squared. This is the number that you will get to know intimately over the course of this year. So negative 9.8 meters per second squared. Really important to note this negative here, okay? That negative is super important. That tells us that acceleration, the acceleration vector is pointed down toward the inside of the Earth or toward the surface of the Earth. So you need to make sure that when we're doing problems with the big three and our acceleration is from gravity, or we're talking about an object falling or being thrown through the air, make sure that your accelerations all have that negative sign. It's super important. All right. So if we look at these examples, we've got the student drops their homework down a wishing well. After 2.4 seconds, it hits the water at the bottom. How deep is the well? So I'm going to let you actually go ahead and solve this problem as practice. But what I want to show you is that we have a time. Got times 2.4 seconds. Okay. And you might be sitting here thinking, well, I'm looking for how deep, and you're sitting there thinking, I don't have a final velocity. How can I do this? Well, you have an initial velocity. If the student drops their homework's starting at 0 meters per second. Okay, so we do have an initial velocity. We're also implicitly given acceleration. If something's falling, our acceleration is negative 9.8 meters per second squared. Okay, so we're going to have to make sure that we remember that even though you might only be given one number in this problem, we only see this 2.4 seconds. We're really given a lot of information by the words. So you should be able to find one of the big three equations to solve this. And the best one, I believe, for this problem would be the second equation. That would be the d equals v naught t plus 1/2 at squared. So you should be able to rearrange, and well, you don't need to rearrange this one because it's already solved for d, your displacement, and that would give you the depth of the well. Okay, and remember that needs to be in meters. And then if we look at the second problem here, a football is kicked straight up into the air at 15 meters per second. How high does it go, and what is its total hang time? So 15 meters per second is the initial velocity. And we're thinking, we don't have a time, so how can I solve this like the last one? Well, a key thing to note is that when you toss something up in the air, it starts at its fastest and then it slows down until it reaches the very top of its trajectory. So when it reaches the very top, its velocity is going to be 0. So we've got this football that's kicked up in the air. Right up here, our velocity final is going to be 0. So that's our velocity final trick. This will be v naught. And this one down here is going to be negative v naught. Okay, so keep in mind that we have a final velocity up here, and we can kind of split this problem into two pieces. So we can look at the path of the football from its first kick until it stops in the middle of the air. And that can give us time 1/2. That can give us half of our time. And then the second half of our time should be the second path that it takes. So whatever time you get for that section, just multiply by 2, and that'll get you time. Okay. So again, we're going to look at an equation, one of the big three equations, that has a v naught and a vf, that has acceleration. Remember, we have acceleration due to gravity. And we're looking for time. Okay, so this one we're going to want to solve for time using one of our equations. And then, so I'd probably use the first of the big three to solve for time. And then from there, you can use your newfound time to find your how high it goes, to find your displacement. How high it goes, you're going to want to use time 1/2. Hang time, you're going to want to use the full time. Okay? So those are some tips and tricks for solving problems with the big three, including using, I'm going to use my pointer there, including using free fall. So keep that in mind this week as you practice these problems, and let me know if you have any questions. Thanks. Bye.